Hello all. Today we are solving LeetCode problem number 3548 equals sum grid partition 2. So yesterday we have solved the first part. So this is very similar to that particular part, but there is a slight different changes, and it is due to that particular change this problem is very hard actually. So let me read out the problem. So you are given an m cross n matrix name grid of positive integers. Your task is to determine if it is possible to make either one horizontal or one vertical cut such that each two resulting sections formed by the cut is non-empty and sum of elements in both sections are equal. So it's pretty similar condition which we used yesterday. Or equal or can be made equal by discounting at most one single cell in total from either section. So you have two sections actually, so you can you can remove at most one, so which means you can remove exactly one single cell from any one part of the section such that sum above is equal to sum below or sum left is equal to sum right. So that is the condition. So if a cell is discounted, the rest of the section must remain connected. So it is not, you cannot remove any cell from the middle, and this will interrupt the connection between the consecutive cells, right? So you have to remove or disconnect the cells in such a way that it does not disturb the connectivity of other cells. So a section is connected if every cell can be reached from any other cell. That is exactly the definition they have given here. So let us understand by example 2. So according to this problem, if for example, if we are having this grid as 1 and this 7, right? So if we are having 6 here and 3 and 4, so this horizontal cut results in 7 on top, means sum is 7 on top and 7 is below, so you can return true. So this is also correct, and by this you can clearly see that when you are having a vertical cut, you get the sum in left as 4, which is 1 plus 3 is 4, and just 4 is 4. So you have the sum in left hand side is equal to the right hand side, and then therefore you can return true. But you are here, in this case you are removing this particular or disconnecting this particular cell. So that is the one and only difference. So how do we solve it? So here we have to track down cells actually and its value. So not only this, we have to locate and location. What exactly this means is uh, this will have the value of the cell, which means the number, which is 1 or 2. So and the location, which means the coordinates, so x, y, or it can be ij, because that is what we are going to use in iteration, so ij. So based on that you can track down the position and you can check if it is safe to disconnect. So for this particular tracking purpose we can use hash map, right? But not exactly this hash map, because we need to have the value stored and you have to have the coordinates. And it is not we also need to note that where exactly this value is starting and where exactly the last occurrence of the value is there. So we need these two, because maybe the starting position can be in the leftmost top, right, which we can remove, or in the second, in the next row actually. So we can remove this, which will not disconnect the other cells, right? Or this can be here, the starting position, or here, or maybe the starting is here and the ending is here. So if we remove one of this and one of this, any one of this one or this will be a valid one, right? So in that case we have to track the last occurrence and the first occurrence of it. So hence in the map you have the key as value, and you will have a list which will store the first occurrence and last occurrence in uh, tuples. So you will have ij and ij. So which means, for example, this map will be represented by 1 as ij and ij. Only two tuples are possible, so you will have key as 2 and the index, and I mean the list which stores the coordinates. So it goes on like that. So this is how you will store it. And now we come into the main part, which is, but after storing this, how do we verify, how do we check? So for checking purpose, as I said, if you see this particular splitting, so here if you're having sum as 10 in the below one and the above one is 9, so in that case you have to remove 1, right? So because 10 minus 9 is 1, so you have to check 1 if it is anywhere present in the below position, below portion, occurrence of 1, that you will check in this map, this scene map. So you will check for 1 and you will check the coordinates, available coordinates, right? So for example, the starting point can be this, the first point, and now you will check if it is safe to remove this. So if it is safe to remove, then you can return true. So for this particular checking, you have totally 3 cases, 3 different cases, because you will have a single column 1 and a completely full or the big matrix which has more than 1 column and 1 row, and you will have single row also. I mean, after partitioning you will have single row. So you have to deal with all these 3 cases. So let us check them one by one. Yes. So looking at this position, we have only single column. So let us write down the scene matrix, I mean scene map. So you have 3 to 5. So which means we can actually divide here. Looking at this, we can divide here, removing this particular value. You have these two partition, right? So in the down below partition, there is no changes required, and only thing is we have to handle in the above part. So now in the scene matrix you will have 3 as the starting position, which will be, you have 3 0 0 as a starting position, and this will be 1 0. So 0 0 is the starting position, and the last occurrence of 3 is 1 0, right? And 2, the starting, and I mean the first occurrence and the last occurrence remains the same, so it is 2 0. So now this is done, the scene map is ready. So now we have to calculate the sum totally. So you have 5 here and you have 8 here, right? So subtracting these two you get 3. So now you have to check if 3 is present in scene. So if yes, okay, so if yes, you have to check if it is but if it is there, and if the starting position is 0 or the first, then we can remove, right? If it is first, definitely we can remove. So in that case, you can return true. So in terms of expression, if we want to write it, we can say that this condition is valid for column as single column. So m, if it is equal to 1, okay, or then the first occurrence is 0, so is 0, and last occurrence is whatever, maybe the I, because that is what we are going to iterate. So if it is I, then you can return true, right? So this is the first case. So let me change the color. So in the second case, you have single row, the half of the matrix part actually. So here also, if you check, this is the partition. So if we calculate the number, we are getting 3 and 4 and 6. So 6 here and 4 here. The difference is 2. So now let us construct the scene matrix, scene map, which is, you have 1 and 2. So we have to check in the top. So you have 1 and 2. So 1, the first occurrence is 0 0, and the last occurrence is 0 2, and for 2, the first occurrence is 0 1, and the last occurrence is 0 3. So now we have to check if this 2 is in scene. So clearly it is in scene, right? And if you check, one is here and the other one is here, right? So now, since it is in the last position is something, the this is the column, right? So column is determined by m. So the m, this 2 lies in, 2 is in m minus 1th position, right? So it is due to that reason we can return true. So how do we check for this condition? So because we are having column greater than 1, so if m is greater than 1 and this row, right? So row is determined by I, because that is how we are iterating. So I plus 1 is equal to 1, okay, and now the first occurrence should be 0. So first equal to 0, or okay, because the first occurrence of 2 is not 0, okay. So next check is last occurrence should be m minus 1. We could clearly see that this is present in m minus 1th position, so this is true. So that is the reason we can return true for this. So moving to the last part, here we can see that if we are partitioning by this, we are getting 4 here and 5 7, and this is 6 7 8. So we are getting 12 here, and again 4, then followed by 4 8 10. So we are getting 10 here. Hold on. So this is 4 4 and 4 8 and 10. This is fine. No, yeah, this is 10. This yeah, this is 10, and here it is 2 6 7 9 10 11 12. Yeah, I'm so sorry about the confusion. So this is you know 2, so the difference is 2. So now we have to check if 2 is present, but this will not work actually, so which means I have to reduce it, because maybe I can change this to 1. So yeah, now this will be 11, because 2 is not in this portion, right? So you cannot remove that, you cannot remove 2 cells, so this will not work. So for this example, this is the correct example. So now the difference is 1, So now scene map will be, you have 1, the first occurrence is 0 0, and the last occurrence is 0 1 2 3. So this will be 1 3, yeah. So 0 0 and 1 3, and you have 4. So the first and last occurrence is same position, so which is 0 1 and 0 1. So now 1 in scene, yes, that's true. And also the the row and column is greater than 1. Okay, so in that case, if it is there, there is no requirement to check actually. So because if it is greater than 1, in that case it is not required to be in corner, right? Because you can have it as anywhere else, because this one we can remove, here we can remove, and here we can remove. Then what else we can remove? Like we can remove in many positions, right? So there is no requirement to check. So if this is greater than 1 and if 1 is in scene, then always it will be true, so we can return true, right? So this is how we will be checking if valid. So this consumes time complexity of big O of n square. So these three conditions are required to check if that particular matrix is valid based on this condition. So now we have to check row by row, or this is for horizontal, and column for vertical, right? So here we will check left to right and right to left. So in that case, what we can do is we can check the regular grid and reverse grid, so which is grid of slicing function -1. So this is one possibility. And for this, again, for checking column, we cannot write the same code, right? So because of the repetitiveness, what we can do is we can transpose the matrix. So this column becomes the row, and now check. So we can do that. So we will use transpose grid and then again reverse check and regular check. So this is all about the complete idea. So with this idea, let us go ahead and code this up. So as discussed, we will have a just check function which will check if the partition could be made. So first I think we can start with that. So define check, where we get an input matrix or grid. So we need just a parameter. So now n is equal to length of matrix and m is equal to length of matrix of 0, because we may not know, right? So when we are getting transpose of that and passing as a parameter, we need to have always the length and length, sorry, not length, row and column to be calculated. So that's why n and m is calculated. So we will have current is 0 initially, and then we will have scene map, so where we will have stored tuples which will have the corresponding location of the first occurrence and the last occurrence of that particular key, right? So now for I in range, we will run this till n-1 times, and for j in range we will run this till m times. So we are removing that particular entry, right? So now we will have the value is equal to matrix of I and j, right? And current will be increment. You have to add current increment with this val or matrix of ij added to this current, so we can track the current. Now if we have to check val in scene, so if already there exists the tuples value for that particular value is being filled, then we have to check if value in scene, then scene of we have to update the last occurrence. So the first occurrence will be stable and the last occurrence we have to update, right? So which is value of 1. So 0 indicates the first occurrence and 1 indicates the last occurrence. So mark ij. So now this is done. So else part, you will have no values there, so since you have to create a new entry for it, so that in that case scene of value will be equal to, you will add a list where you will add two tuples, which is ij and ij, because that is the first occurrence and the last occurrence, right? So now this is done. So now time to calculate the difference, right? So difference is equal to total, which will have the total sum minus current. So now if this is equal to 0, different is equal to 0, then the condition is satisfied, so we can directly return true. So if equal to 0, then return true, right? So and now comes the next part. If minus different in scene, so we have to extract the front row and front column and last row and last column based on the tuples value actually, and then we will check the 3 condition, right? So first let me take that. So first row and first column is equal to scene of minus difference, then 0. This is the first occurrence, and last row and last column is equal to scene of minus difference, difference of first. So now that this is done, now we have 3 condition to be checked, which is 3 cases actually. So the first one is we will check the big grid, and then followed by single row and single column matrix cases, right? So now if m is greater than 1 and I plus 1 is also greater than 1, so this indicates definitely it's a big grid, it's not a single row or single column one. So now we will return true because this is true for all cases. And next is if m is greater than 1 and I plus 1 is equal to 1, so in that case you are handling single row part. So you have the other condition, which is for the if the first row is equal to 0 and the last column is nothing but the m minus 1, then in that case we can return true. This is for one row case. So and this will be first column or the last column is equal to m minus 1. So m minus 1, so in this case you return 2. And again, now for single row, so now in this case m will be equal to 1, and you will have the same condition, which is first row, this case row, or if this is true, or so this should be equal to 0, right? Yeah, first column should be equal to 0 and last column is yes. So first column is again, first row is also, I mean, again equal to 0, I'm sorry, last row is equal to I. So in this case this will be true. So now these conditions are done. So we have successfully defined the check function. So now we have to handle the cases, which is we will be finding the total value, and then we will be checking for the matrix, or I mean the grid, and the reverse of grid, and then transpose. So we will check for all those cases, and then we will return the answer. So now n is equal to length of grid, and m is equal to length of grid of 0. So now we have to find total. So for I in range n, for j in range m times, now total, we have to have the value assigned as the total is equal to 0 initially, and total plus or equal to grid of I and j. So now total is calculated. So now we have to check, I mean use the check function to check for grid and reverse of it. So if check of grid or check of reversing of that grid actually, so oops, add any grid actually, I mean I did not pass the parameter grid of reverse. Any one of this is true, so return true. And now we have to handle the transpose. So for handling transpose, we will have new grid created as an empty list, and now we have to iterate it. So for j in range, we will run this till m times, and we will have to have a new row array. So new row, this is also an empty array which we will store all the rows. So now we will iterate, and then we will append the grid value into the rows. So for I in range till n times, new row dot append, we will append grid of ij. So you will append it, and then end of this loop we have to append that into the new grid. So because we are done finishing the new row array, and now we have to append back that to new grid dot append, we will append the new row, right? So this is done, and we get the transpose. So grid is equal to new grid, or yeah, I think this is not required. We can use the check function for a new grid only. We will pass a new grid, so we will copy this. It's the same, and this should be replaced with new grid. Yes, and if nothing works, return false. So yeah, so let us run it. this should be equal to, again this should be equal to, if m is equal to I. Yes, I don't know, I have to check if I have missed something else. Yes, it's working, so let us submit it. And there you go. Thank you.